Hi. Let's wait a couple of minutes, right? So for everyone to join up, then we can start today's talk. Okay, let's begin. So good afternoon, everyone. I'm Dr. Lim Ching Wei. I'm assistant professor at the Department of Statistics under CHS and under Faculty of Science under CHS. Right. So today I'm going to share with you our statistics program. And the topic, as you can all see, is that statistics is in demand. Right? So I hope that I can share with you how exactly it's in demand, right? Where it's in demand and why it's in demand. Okay, so to start, that's a brief introduction to the department. Right? We have 31 full-time teaching faculty, dedicated teachers, right? Highly regarded internationally. Right? If you go ahead and Google best statistics programs in the world, right, you will see that our program is consistently ranked pretty high. Okay? Both in terms of our undergraduate education as well as our faculty's research output and so on. Okay, we have accomplished scholars with diverse research interests. Okay, and this includes modern hot topics like deep learning, machine learning, financial statistics, but also we are experts in the classical topics fields in statistics, right? Causal inference, missing data, Bayesian inference, computational biology, infectious disease modeling. Does infectious disease modeling, of course, is really hot right now. And I want to point out that someone you've been seeing over the news, Professor Teo Ik-ing, who is the Dean of the Sussex Hall School of Public Health, holds an appointment in our department as well. Right? So he came back and was a professor in our department before moving on to head up the School of Public Health there. So that's our department. Let's get on topic, right? What is, where or why is statistics in demand, right? So it's in demand because it is really very widely applicable, right? It cuts across different domains and applications. Okay? Right now, the hottest topics, right, or at least in the local context, the hottest industries is, as usual, the banking, financial, accounting industry in Singapore, right? Singapore being a key financial hub in the global economy, right? It's used in investment banking, risk, data analysis, right? Healthcare, very big topic in the world right now, right? Epidemiological, pharmaceutical, clinical research, right? All our vaccine research and so on. But outside of these specific mature industries, right, there's also the how widely applicable statistics is also demonstrated in our role in consultancy, right? In marketing research, ratings firms, right? These are across all the different domains, right? It's because the tools that we teach, the skills that we teach, right, are applicable in a very wide setting. Right, and that's the private sector, right? Marketing research, ratings, customer analytics, and intelligence. These are all private sector things. And the public versions, in our ministries, in our stat board, we also need these kind of similar types of skills, right? And they continually also be looking for these students or graduates to fill those spots. So I'm going to hold the questions until after the presentations, right? But feel free to put them on the chat box, right? So then we'll get to them afterwards. Okay, so just to demonstrate, right, a quick demonstration of how or where or how diverse our students are, right? These are employers of our recent graduates, right? All over the place, right? In the public and private sectors, across the different industries and domains. Okay, so let's talk a little bit more about the actual applications, okay, that will relate to the kind of skills and techniques that we teach in our curriculum. Okay, so a big one, electronic medical records database. Right? So traditionally, right, medical records were just paper records. And to be able to diagnose someone, doctor would typically look at your records and based on his experience, be able manually, one by one, right, tell you, okay, based on these, perhaps you are more predisposed to diabetes, let's do these tests. Right? But today, our medical records are all electronic, right? So we are able, right, so one way of making use of these large electronic databases, right, is to formulate what we call patient risk scores, right? So it takes very basic, cheap, efficient measurements, right? Things like resting heart rate, like sugar level, weight and height, age, right? Things that are easy to collect, and use an algorithmic model, a statistical model, right, to evaluate based on these input variables, what kind of risk you have for the various types of diseases. So this is, it takes away, it makes it a lot more efficient, right? Allows our doctors to work on the more advanced stuff. Okay? And can for certain cases, right, based on these data, right, you can even identify what kind of treatment will help. Right? So that's one. Two, right, insurance claims. Okay? So again, right, insurance is everywhere now. We have insurance for almost everything. And as the way the insurance works is that there will be a subset of people making claims, right? And insurance companies, of course, will be looking to process these claims and to pay out the legitimate ones. Now, traditionally, of course, again, it's a manual process, right? You look at each claim, determine whether it's believable or not, and then you give payout or not. Okay, again, because now we are all it's back to electronic, I mean, it's all compiled together in an electronic database. You're able to do more than that, right? You can do it in an algorithmic way. That's one, same as the patient risk thing, right? That's efficient. But another big bonus that you get, right, is when you can identify certain patterns that come in these large number of claims, right? So when you manually process these claims, already is inefficient, let alone trying to extract patterns from a large number of claims. And that's very difficult to do, right? But statistical modeling allows us to do that. Okay, and in that vein, right, that brings us to our third example over here, right? Points of sales data. Right? Again, this is something new, right? Traditionally, a cash register, it prints out a receipt that doesn't say very much, right? Now it goes in a central database, right? And based on just these kind of spending habits, right, which items are bought together, right, you can make improvements to retail, right? Very simple thing like, oh, actually, customers who buy item A also often buy item B, right? So maybe we should just put them next to each other on the shelf. So those who didn't, maybe they forgot, maybe they didn't realize such an item existed. Right now they are incentivized or they are they're motivated, they're targeted to buy them together. Right? So this improves customer experience, right? Improves the revenue of the company. Okay, so those are very specific examples. Okay, but in general, right, business decision making, we can break them down into different parts of our statistics process. Okay? So this is not always the case, but generally you can break it down into these kind of different steps. Right? So first you look at the descriptive statistics. Right? How do you display, make sense of the data that we have? Okay? So this, at a very basic level, this is just looking at summary numbers, looking at charts, how to display them, right, to extract meaningful information. Okay, and this can get pretty involved, right, to which we get into something we call exploratory data analysis, okay, to dig a little bit deeper. But the goal here is really just to understand, right, what is happening now and what has happened before. Okay, so that's descriptive part, right? That's some value in understanding it on its own. Okay, but that also allows us to go into the next step, right? If we know what's happening now and what happens before, right? Naturally, we can try to extrapolate, right? Try to make prediction models. This is predictive statistics. Okay, allows us to identify trends and make predictions. Okay, so that's great. If we can do this well, this is fantastic, right? So if that allows us to project what will happen, right? That can help us optimize or plan ahead better. Okay, and the third part is, well, if we have a model based on the present and the past, and I'm able to make good predictions, but our predictions were not ideal. Okay, based on our current trajectory, we're gonna do quite badly in the next quarter. Okay, what are we gonna do? Okay, so that's where prescriptive comes in, right? The what if, right? What happens if we make certain changes? Right, based on the model that we have before, right? Perhaps if we make certain business decisions to change some of these input variables to our statistical models, right? That would allow us to get better results, more desirable results for our businesses. Okay, so this is not specific to any industry, right? These tools allows us, right? All these parts, these descriptive, predictive, and prescriptive tools can be applied to all these different domains. Okay, so who uses statistics? Okay, I mentioned earlier, it's all over the place, right? Health, business, research, government, environment, etc. Okay, so I'll get into a few specific examples, right? More examples, but I wanted to, across these different applications, right? The key, right? What is the role that statisticians play? And maybe to answer some of the questions that are flooding in, right? What's the difference between statisticians with data scientists, with business analysts, and so on, right? So our statisticians, right? The goal, right? What is core to us is the expertise for design analysis and across these different types of domains, right? Complex surveys, experiments, research studies, right? Any kind of collection of data, we design and we can analyze, right? And we are the experts behind these models, right? We fully understand what they mean, what they can say, right? What are the conclusions that can be made, right? So this allows us, right, to inform people, right, have them make informed decisions. And the key, right, I think the one thing that sets us apart from all the other more applied domains is that we are very, very focused on this thing called uncertainty. We don't only care just about the expected results or what is the right move to make at this point, but we always take into consideration what the uncertainty is. We want to quantify not just how much money we can make, but how often we make that money, the expected money that we make. Okay, what is the margin for error? What is the distribution of that error? Right? So these are things that are very core to statistics. Okay, so come, let's look at some even more examples. Okay, so banking and finance, big one, right? How to make money. Okay, so we combine knowledge, right? So statisticians, the key program, right, is to teach statistical skills. But one of the very important lessons is also that we always want to inject domain knowledge experts. Right. So if we combine the knowledge between our statistical modeling with financial principles, right, financial knowledge, learning from history, learning from things that are known to work now, right? We can conduct financial analysis and make good financial decisions. Right? And applications, right? What you actually use them for? We evaluate investment strategies. Okay? You can forecast asset prices, you construct trading rules, perform risk management. Okay, so all these things people do, right? In the applied fields as well. But what we can offer, again, is the whole idea of uncertainty, right? We are very concerned. We quantify our uncertainty. We are very clear on our assumptions, when things can go wrong, what kind of statements do we make, right? What does it mean when we say that we expect this kind of return or this kind of prediction under our models? Okay, so the understanding, the interpretation of these statistical models and results and strategies, right, is key to our education here. Hey, consumer research. I talked about the grocery store, retail before, right? But more than that, right? We can also look at businesses that are not already there, right? Before businesses launch new products and services, okay, the typical process is you go ahead and get investors and then you launch it. If it works, great. If it doesn't, too bad for the investors, right? But statistics can help here, right? We don't have to just go in blind. We can make projections. Okay, so we can relate it to current businesses, draw key features to help us predict better. Right? We can design experiments to help us assess that. Right? Maybe do a small field experiment, a small test market, small version of it. Right? How to extrapolate from these experiments to what will actually happen. Right? We can conduct surveys. Right? What do these surveys, right? The result of these surveys, how does that translate to how viable your business is going to be? Okay, so all these things is part of statisticians. Domain. Yeah. Okay, policy making. Right, that's a big one. So the Singapore Department of Statistics, right, is a stat board that collects statistics, do a lot of sampling. Actually, later on in this presentation, one of our students interned there. Right, you should talk a little bit about the work that she did there. But it's a central resource, and they actually publish a lot of studies that is open to public. So if you were interested, for example, in HDB prices, right, history of it, you can go to SingStat and download those data sets on your own too. Okay, so the data there is collected, it's used, right? But who's gonna figure out how to use them, right? That's where statisticians come in. Okay, so this is why across the different ministries and stat boards, right, they look for statisticians to come in and fill those roles. Okay, they are vital, right? We need to make sense of these data, right? Look at models, understand what they mean, right? For economic, social development, right? Policy formation, evaluation, right? All across the different parts and branches of government. Okay, medicine and public health, right? Again, this is a big thing now, and I talked about it briefly earlier, right? So with the large amount of medical records that's electronic now, right, we're able to make better decisions, more efficient decisions, right? Construct models to help us figure out what is optimal to do at each point. Okay, so one thing that I think is very relevant and relatable now, right? Today, vaccines for COVID is available here in Singapore. Okay, but there is a lot of, some skepticism in the safety of these vaccines. Right? So biostatisticians, right? Some statisticians who specialize in the bio field, right, are able to can do their part, right? They can make sense of all the research that's been done, right? Explain to people, to government, for example, who's doing these policies, right? Why it's safe, how it's safe, right? What does it mean when you go ahead and vaccinate the entire population over here? What is the side effect? How to quantify, right? People worry about these side effects, right? Is it a cost that's reasonable? Okay, I have full confidence, right? That's what's happening in the ministries, right? People making sense of these research, making sense based on these statistical models and skills, right? Based on the results from the research that tells us, that helps the government make these decisions that yes, this is the right thing to do for us at this point. Okay, so I hope I have conveyed why statistics is important, right? Or at least why it's in demand, right? And all the different ways it is used everywhere. Right? Okay, so the next natural question is, okay, statistics is a good thing to study, right? But why statistics at NUS? Well, the answer is quite simple. It's because NUS is the only university in Singapore to offer a degree program in statistics. Right? Okay, there are, of course, many other, again, related to some of the questions you're asking here. There are a lot of different programs that have some overlap with statistics, right? And some of them will learn certain skills that I've described, right? But here, statistics at our department is really the core statistics. Right? We are equipped, as you'll see later on in the curriculum description, we're equipped to go in any direction, but our goal is to make sure you can go in any direction. Right? So it's a think of it as a starting point. Right? If the possibilities here described above excite you, right? You don't have to choose right now. Taking a degree in statistics allows you to go in any direction as you choose later on. Okay, so our program, right, is an honors degree, 4-year program under the CHS, right? Our primary major in statistics is a 60 MC curriculum, just like any other program in the CHS. A prerequisite is a simple one, right? Just a H2 pass in math or FM or equivalent. And if you so choose to, which you don't have to decide right now, right? You still choose to, if you think data science or finance is particularly interesting to you, right? You have the option to specialize later. Yeah. So you have a degree, major in statistics, and a specialization in one of the two fields. That's on top of the 60 MC requirement. Again, we'll talk about a little bit more about that later on. Okay, so again, our focus, our classes, right? One key thing I think that sets us apart from the other related programs is we emphasize on problem formulation, statistical thinking, right? So we want to be able to come up, to formulate, right, the problems. What is it about this data set that what kind of problems can we answer? Right? Statistical thinking, again, revolves around the uncertainty that I was talking about earlier on. Okay, what we don't do only, right? I mean, of course, we do the application basic statistical methods as well, right? But we don't just do a plug and play, right? We don't just take a data set, put it into a program, and look at the results, right? We care about the underlying principles. We want to make sense. We want to do our inference on what those results mean, right? What are the assumptions? What are the actual, what do we actually mean when we make those statements? Okay, so the interdisciplinary nature, right? Statistics on its own, even though I'm trying to sell statistics as more core than other programs, right? On its own, at the very core of statistics, right? It's still an overlap between different fields, right? In particular, our probability models, right, come from mathematics. Okay, it's we need foundation in there to fully understand what we are trying to describe in our models. Okay, and to actually run our models, to get our predictions, we need to understand how to program, right? Computer science, how to deal with data, digital data, right? Which is pretty much the core of what we do now, right? Comes from computer science. So our curriculum reflects that, right? We don't skimp on that. We go straight to the core, right? Go take up properly, learn what the math is behind our models, learn how to do computer science properly, right? and look at the foundation based on that in our core statistics curriculum before moving on to the more fancy, to the more niche and applied classes. Okay, so you can see that from our curriculum structure. So our 1000 series course, right, is the Introduction to Statistics and Statistical Computing, right? Just like every other major program in CHS, we have one that introduces our major to all our students. Okay, that on its own is great. I fully recommend, even if you don't want to take a statistics major, to take this class, right? Because it tells you what quantitative reasoning analysis is, right, in today's world. Right? You learn some basic concepts in statistics. What do some of the statistical terms mean? Right? How to get the results, right? Using a free software R. Okay, very popular and free, right? You should. There's not much reason why anyone in today's world don't have this. Okay, you can very quickly do statistics easily with R, right? So level 1000 lets you do that, right? And when you go through this course, right, hopefully you will feel like you want more. Right? These are all the different, you look at very basic things, but you're also exposed to things that, the shortcomings of all the things that you're doing. Right? And that's why there's a whole program here for you to work towards. Okay, so once you're teased and realize this is a good thing to do, okay, so this is when we really dive down to the fundamentals. Right? So I mentioned earlier, do linear algebra and calculus properly, right? Take the actual math classes from the math department, right? Learn how to learn these basic foundations. This is required, necessary for building our statistics knowledge. Right? Also, we have a statistical computing class. Okay? This R is nice and getting more and more popular by the day. Okay, but there's also other platforms that people use, and depending on the industry you want to go into, specializes or use some of these other programs exclusively. Okay, so in this course, it's required in our major, right? You'll be exposed to R, Python, and SAS. Okay, and it's nice because that if you can handle 3, I think you can handle anything. Because if you learn how to look at things abstract, right, this is just a matter of syntax going forward, right? If you can handle 3 different languages, 3 different platforms, even if a new one comes 10 years down the road, right, there's no issue for you to jump, to just get on that and learn the syntax there. Okay, and sandwiching these 2 foundational courses is our core statistical curriculum. Okay, my students, I've taught these 2 classes, and my students always tell me, my FYP students, my final year students, always tell me that these are the most difficult classes in the whole major. Okay, and that's not a coincidence or surprising, right? Because this is the core of our statistical education. Okay, we learn how to rigorously define what probability is, okay, what random variables are, right? What it is. If we know the truth, right? How are things supposed to behave? Okay, that's kind of the topic of probability. And from there, we move on to mathematical statistics, which turns that around. Right? Now we have some data. How do we infer the truth behind it? Okay, so that's kind of the yin and yang of our probability and statistics. Okay, so these 2 classes are very rigorous, right? They demand, they build on the mathematical foundation that we make you take first. And they themselves form the foundation for higher level modules. Okay, you have to slave through them, right? They are difficult modules, but once you're through them, now you're prepared. Right? Once you're done with 2000 level series, you can do almost everything that we have to offer. Okay, so this includes more advanced, more niche type of methods, right? Important regression analysis. This is always the first thing people do in any domain, right? Do some regression first. First step they take, so that is a core requirement. But everything else here, right, it depends on the type of data, the type of industry you're interested in. And you may be interested in categorical data, you may be interested in more computer intensive type of methods, right? You care about non-parametric type of statistics. Okay, so these are tools that handle specific types of data. Okay, if you want, right, you are allowed to take all of them. Right? You want to be the master of statistics across all the different types. Yes, you definitely can. Right? Okay, for those who are more focused, right, who would like to specialize, has, after taking the first 1-2 years, you realize your career interests is in certain fields, right? We offer more specialized classes as well, right? So of course, the 2 specializations speaks for itself, right? Financial and business statistics has its own classes. Data science has its own classes, right? And again, these are not specific to they're not exclusive to those who do the specialization. So you're allowed to pick and choose if you like. But the specializations, the programs that we have, right, is more of a curated list. Like if you want to be well placed, right, going into those fields, right, these are the set of classes you can take. Okay, but on top of that, right, we also have other classes that are more specific, right? Medical and public health data, for example, right? These are some classes that you may want to take if you're more interested in the operations, right? Amazon being the #1 company in the world right now, right? There's other classes we deal with these industrial statistics. And that's just the classes you take. That's not the whole education we offer here. Right? We also have career development opportunities. And this manifests in 2 major ways. Right? So one is that, remember the distinguished faculty that we have, right? You can not just take lessons under them, but in your final year, you can choose your choice. You don't have to. You can choose to do a final year project under a faculty member's supervision. Okay, so this allows you to get a taste of academic research, right? Do things in a really rigorous manner. Okay, so actually I have a video to show for 2 videos to show, right? Illustrating these 2 points. Let me get to that. Right, so the other one is the other main career development opportunity that we offer is the opportunity to do internships with industry partners. Okay, so this is primarily through the undergraduate professional internship programs. So there are a lot of opportunities that look for statistics majors. You are also welcome to find your own internships, okay, and add that to our UPIT portal, right? Subject to approval, relevance, and so on. Okay, but this is something which a lot of our students do and find very useful in terms of career development and even seeking employment. Okay, so again, these are just some of our examples of students who have interned recently. Okay, so I'm going to show 2 videos. These 2 videos actually were recorded last year for the open day. And they are very dear to me because both these students were my students who went through the mathematical statistics, again, the notoriously difficult course I mentioned earlier, but also the statistical learning sequence, which I teach regularly. So the first student is Enzio, who did a research project with one of our faculty member. So I guess I'll let him speak. Let me see. How do I share audio? Okay.
Hi everyone, I'm Enzo, a year 4 student majoring in statistics. I'm currently working on my final year project, or FYP. My topic is on particle swarm optimization, or PSO, which is a type of meta-heuristic algorithm. PSO is influenced by ideas from social psychology, where we want to consider how an individual is affected by its surroundings. We try to model our algorithm similar to how animals behave, like in bird flocks or fish schools, things that happen in nature, or even biological or genetic processes, such as mutation, crossover, and natural selection. There are many applications of meta-heuristic algorithms in practice. These include applications in image processing, engineering applications, and also in cancer detection. If you're interested in research in statistics and probability, I strongly suggest that you come to the NUS Statistics Department, because I think that this is a place where you can really explore your interests, as I myself have benefited greatly from the experience here.
Yeah, he was a little bit nervous, but I hope you see. I mean, he definitely benefited and enjoyed his project, and he learned a lot, and very interesting topics. Okay, so the second video I wanted to show you was another student who actually did multiple internships during our program. Okay, and this was recorded last year again while she was a year 4 student, and she was at that time interning with Abbott Laboratories, right, a pharmaceutical company. Okay, and actually, right after this, after it was recorded, she was actually offered a position, and she's working there now. And so this is a success story of our internship program. Sorry, yeah, this one.
Hello, I'm Jiayun. I'm a year 4 student majoring in statistics at NUS. So during my 4 years here, I did 2 internships. The first one was the undergraduate professional internship program with SingStat. So over there, I got to apply knowledge in demographic statistics and survey methodologies. And it was basically for the household expenditure survey in 2017 and 18. The second one was the recently introduced applied project in statistics. So this one I got the chance to do it with Abbott Laboratories, and over there I got to apply statistical concepts such as unsupervised learning and time series analysis to help the company do demand forecasting. So not only are internships important in helping students tie back the concepts they learn in school to the real world, they are also very important in helping the students decide if this particular field is the right one for them.
Yeah, so some success stories, right? So hopefully you are swayed by them. Okay, so before I go, right, let me just round off the talk with how we integrate with CHS, right, which I'm sure you've been hearing about all day. And it is really fully integrated, right, with just like any other program. Right? Our major program is 60 MCs. Okay, it's fully compatible with double major degrees programs within CHS. It is also possible to do double major degrees outside of CHS, right? Subject to the usual overlapping or feasibility constraints. Okay, on top of our primary major, you can do a specialization, okay, and that is 20 MCs on top of the major requirements. You can also do statistics as a second major, right? So the 60 MC was for a primary major. You can also be primary major somewhere else and do a secondary major here for 40 MC. And if you don't have the MCs to spare, there's also the minor program for 20 MC. Okay, so these are all tiered and structured but without losing the core of what I was describing earlier, right? So certainly 60 MCs you can accomplish more than 40 than 20. Okay, but at any level here, right? We are trying to, we have the same set of classes that really tries to develop this core statistical skill set for you. Okay, and this is a sample study plan, which I think you have access to. I just want to illustrate again what it looks like. Right? So what's in blue is your core curriculum requirements, right, under CHS. So what's left over in green is your major, right? So you see that with the 60 MC structure, basically you take about 2 classes every semester, you'll be okay. And as I went over earlier, right, the first one is the introduction course, which I encourage everyone to take. Then we work on the fundamentals in math. Then we look at the fundamentals in statistics, right, 2132 and 2131, probability and mathematical statistics. And also the core classes, the regression analysis, statistical computing. And afterwards, it depends on what you want to do. Right? You're free to shuffle them around. Okay, so these provide the prerequisites that you need to take the more advanced classes. Okay, so at this point, you can also, if you choose to, right, embark on the internship programs, right, or the exchange programs, right. You can use, and that will fall under your UE space, right. So you can shuffle these around to make space for them. Okay, and the last point, I've talked about the undergraduate here, but actually our department offers more than that. Right, we also have research programs to go all the way to a PhD. We have coursework programs leading to the masters. Okay, so we really do it all. Okay, so really that's all I have for you today. I will try to get through the questions And there's also a specific Q&A session later on at 5 o'clock. So you can also join us there. So I think with us right now is Professor Chan Hock Ping and Professor Lim Tiong Wee, right? So that's the head and deputy head of the department. So maybe they can start addressing some of the questions while I take a quick breather.
Hey, Jinghui, hi.
Hey,
Okay, hi everyone. I guess one of the common questions that many of you have is regarding what's the difference between statistics and data science and analytics, right? And both of these are actually offered by the department. So in the data science and analytics major, there are more compulsory math and computer science modules that you have to take. Whereas in the statistics curriculum, there's less compulsory math and data science modules that you need to take. But that doesn't mean that you should not take those modules. I mean, you can always take those modules because it is also important to have all this background, right? Especially in computing, right? When you go out to work, you do need those skills. So I think that would make some the key difference between the two majors. John, you anything to add? You want to add in?
Yeah, I think you're spot on. Because the DSA curriculum, assuming some of you have heard my talk earlier, we do have numerical computation and complex optimization as compulsory integrated modules within the DSA curriculum. These are math in nature, and these are not present in statistics. So by design, they are a little bit different. And I think there were other questions earlier relating also to how much math rigor is there across the different majors, like statistics and even DSA. Perhaps instead of addressing the difference in the math rigor, I perhaps would like to point you to the similarities in the foundational preparation for these various majors. Okay. Like I mentioned earlier, assuming again you were in the DSA talk, the DSA major this year is a major you can declare, which is very different than in previous years when the DSA program has to be applied to directly. It's a direct admissions in the past years. So the beauty of that then is the following. Whether it's DSA, whether it's statistics, or even to some extent mathematics, the foundational preparation in mathematics is common. Okay, and what we used to advise students is the fact that because the foundational preparation is common, transitions between the different majors can be quite straightforward. All right, so rather than worry so much about whether I want to stick with statistics or I want to stick with DSA, try out the modules. The gateway modules are there for you to get a flavor of the differences in the disciplines, but the mathematical preparation is common. Okay, so you can move about between the majors should you make up your mind at a later date, maybe year 1 sem 2 or even year 2 sem 1, and by and large it wouldn't hold you back too much. All right, so rather than coming down to the details of how stat is different from math and how math is different from DSA and so on, try it out for yourself. All right, and make a decision eventually, because now you have the opportunity to do so. All three majors fall under the CHS offering.
Right, I think there's also a question on whether statistics require a lot of computing or do you need just basic knowledge, right? And you can see in the curriculum that there are some compulsory module in computers, CS 101OS. So there is a compulsory computing module you need to do. Within NUS, you also need to do statistical computing and programming. And in many of the modules that you take, they will require you to do some assignment, for example, whereby you use a program R to work with the data, right? So the whole idea is that data is very massive nowadays. You probably cannot do it by hand, right? So in the JC, probably if you let's say about A levels, a lot of the things is done by hand. But in truth, when you go out to work, you really need to have some computing skills, right, to deal with the massive amount of data, right? So there is computing involved in statistics, but not to the level compared to, let's say, a computer science major, right? But I think it's a skill that you need to pick up when you come to do a statistics major. Now, the key thing is that we do not assume that you have computing background before you join us. So most of your classmates are on the same level as you, with perhaps very little computing background, and you'll be introduced to all this slowly, so that it is not very sudden to you. So by the time you graduate, you're comfortable working with those software and so forth, right? So the whole point is that we'll train you to do computing when you come here, rather than assume that you know all this stuff before you join us.
So I think I want to also add that the programming that we do is pretty high level, in the sense that we don't see the underlying bits code, right? So we are mostly scripting more than programming. Of course, there are certain cases where you may want to like really optimize, right? But that's not part of the core curriculum. Right, so for most of our use cases, it's really more using a program than doing hardcore programming.
Yes, maybe I can just say that in R itself, there's a lot of all these programs you can download. So just run the code, for example, and for example regression, right? There's a regression code that you just run, right? But you need to know how to write the code to call these programs and so forth, right? So these are the skills you need to learn.
Okay, I think we'll end the session here, right? And we'll have a Q&A session at 5 o'clock, right? So if you have further or more involved questions you want to chat with us, right, feel free to join that session later on, right? We'll be there for the hour, I think. Yeah. Okay, thank you everyone for coming. Look, okay, great. Melissa has posted the link, right? So do join us there. Right? I'll leave this up for a while so you can copy paste, right? And then we'll talk to you then. Okay, thank you.